Hi, good morning, everyone. Welcome to big data analysis. Right. So, last meeting, okay, we discussed about regression. I hope you still remember. Here it is. Right. So we practice this quadratic equation. Right. At that time, I asked you to create a parabolic model with certain A, B, and C parameter, and then X will be certain random numbers that you generated. Yeah? And then you get the regression to get back A, B, and C, and after that you can add noise. Yeah? And then you check the effect of the noise to the R square, right? So something like this. So when you have no noise, this is exact, yeah, with R square is equal to 1. Right? And then with noise, of course, the points and the line will differ very much. Okay? But the R square also reduce, okay, because of the noise that you created. Okay? Using the same technique that we use for the regression. So we use exactly the same formula for regression, which is actually matrix equation, right? So using matrix equation, this is very awesome, right? Because you can use for any kind of regression, including linear or non-linear. This is polynomial model that you just created. Okay, and then I ask you to create a cubic model, right, for your assignment. I hope you make it. So is there any question about this regression that we discussed last meeting? Oh, can you open your camera? What happened?
No question, sir.
Can you open your camera so that we can get feedback? Right. When you are online, please open camera. That's ethical, right? If you close it, very difficult to communicate. Okay. So this is if you do cubic equation. So this is example of A, B, C, D, E. Okay. Again, we use exactly the same equation of regression. Okay. It is just linear equation, right? L times the parameter here. Okay. You can get back the regression. Now, the same formula, okay, you can also use regression for classification. Okay. So far, the dependent variable y in the regression is always numeric, right? Not categorical. Okay. But some of your data are categorical. Okay. So what's the difference between classification and regression is actually in the dependent variable. Okay. If your dependent variable y, okay, is actually categorical, so either ordinal or nominal or binary, okay, that's been category, right? So then that regression is actually no longer regression. That is called classification. Okay. So now, can we use regression for classification? Yes. Okay. But the result is not that good. Okay. So we can use the same procedure, and then if your category, okay, the y is actually only 2, probably you get a quite good result. But when the number of categories more than 3 or more, okay, the result is not correct usually. Okay, so today we will discuss something else. Okay, today and next meeting, how to do classification. Okay, so the procedure for regression of classification is exactly the same, okay, using generalized inverse, but the final result of the estimate are rounded to the nearest target value. So you get the minimum based on that. This is your data, yi, and then this is your target value. Okay. So this is the example. So suppose I have this x and y, and then because you want to create a discrete value, in this case I created 3 classification, yeah? A, B, and C. Okay, because in regression, so we cannot use that string or A, B, C. So we need to convert it into numbers, right? So that numbers I put here is 0, 0.5, and 1. So this represent A, B, and C. Can you see that? Okay, so this is A, this is B, and this is C. Huh? And then we use exactly the same as before, and this is the actual result. You see, in this case, in this example, of course, pretty good. The result is pretty good. It's quite 100% estimation. But the total misclassification is much larger as the number of clusters increase. Because we use the same gradient to separate the cluster. See, here you can see this is misclassified. The same thing here, this is misclassified. Okay, and if I have 4 category, 1, 2, 3, 4. Okay, so the misclassification is very clear. And so we cannot even use this linear model in this regression. Okay, so later we will use other model, okay, to do a classification. Okay, so this is you can practice this if you want, okay, to separate, okay, these two. I think this is A and B, so we just use into number 0 and 1. Okay, and if you use that, you will use exactly the same value, and then when you predict, you can get a pretty good result. You can see the separation is pretty good. Right? Okay, so the last part of this regression lesson is about orthogonal regression. Okay, so the regression that you learned so far, okay, our understanding is to minimize the sum of error, right? So this is what we call SSE. So this is your YI, okay, and then this is the Y estimate. Okay, this is the model. So you minus the data with the model, and then this represents error, and then you square it, and then you sum that square error. That is the one that you want to minimize. The problem with this technique is, okay, the normal regression, yeah, is if your line is actually vertical, what will happen if your line is actually vertical? You cannot, right? So another technique that is sometimes we call it robust regression. Is, mathematically we call this orthogonal regression. It's also linear regression, but the objective is not minimize the vertical error. This one is vertical error, right? So we minimize the error that is perpendicular to the fit line. So let me draw. Okay, so the usual regression that you have, whiteboard. Can you see my whiteboard? Okay. This is the usual regression that you have. Say, this is your regression and this is your point. Okay. So, when we said error, right, is actually this vertical point. This vertical point is the error, right? In the usual regression. So this is called regression using OLS. We want to minimize the error, and that error is actually vertical error. So that is a really a big problem. Why? Because when your line is vertical, so the error is infinite, right? So in that case, we have another model. We call it orthogonal regression. So the way we measure the error is not vertical but perpendicular, okay? Perpendicular to the line. So perpendicular to the line. Okay, so suppose this is your data point. Okay, that error is actually perpendicular to the line. Okay, using this technique, even if your line is vertical, so there is no problem, because of course if your line is vertical, right? So and your data is something like this, so it's still perpendicular to that line, right? So you can still get the error. Is it clear, the idea? Okay, so now we want to fit the line, which is this is the line equation, yeah? A plus bx plus cy equals 0. Okay, so what is the technique to do that? Okay, the technique is we form the normal unit, which is perpendicular. Okay, how to form the normal unit? We set the p square plus c square equal to 1, so that is a unit vector. Okay, and we want to minimize the square distance, yeah? The distance between the point to the line. Okay, so here is the steps. Okay, so you have a data x and y, right? And then your model is this one, a plus bx plus cy equals 0. And then you form the matrix. Yeah? So because this is linear regression, so this is the form that matrix that is make it different. Okay, so A in here is what? ABC, and P is the parameter, right? So ABC here, A multiplied by 1, right? And then B multiplied by X, right? And then C multiplied by Y. So we have that. This is the matrix A, okay? After that, you compute the distance, okay? You compute the sum square of distance over all row of Q. What is Q? Q is A times P. Okay, so after you calculate the distance, you use solver. Okay, you use solver to minimize that distance by changing this P, okay, subject to this constraint. Okay, so can you practice this? So say you have this kind of data. X is okay. Let's practice first with the usual data that you have last time. Let me share my screen to you. So this is the linear regression that we practiced last time. You still remember? Okay, so if you calculate the slope, okay, and the intercept, you get these two values, right? You still remember our practice, the first practice in regression or not? Can you check the beginning of this slide of regression? Okay, so now if you use the normal regression, you will get this value, right? Okay, and then you calculate this one is what? Look at the matrix A now. This is 1, this is X, and then this is Y. Okay, and the parameter is ABC, right? Can you see that? Okay, and then what you will do, you calculate the Q, right? Q is this matrix, okay, multiplied by this parameter. Okay. After that, what you will do, you calculate the sum of square of this. sum square of this matrix. Okay, so this matrix is Q is just a multiplication of this matrix A times parameter, right? And then the distance is just the sum of square, sum SQ of this parameter. Okay. So, and then you use solver, right? You solve, okay. So, you want to minimize the distance by changing the parameter subject to constraint. What is M7 here? M7 here is this, that the A and B, the B plus C, B square plus C square must be 1. Okay. So once you created this, okay, then you change the data. You change this X and Y data, okay, into something like this. So the X is now equal. The Y are changing. Okay. What happens if you use the normal linear regression? You will get the Y is actually deficient by 0, right? Because of course you cannot get vertical line, using linear regression. But if you use orthogonal regression, you can get that. Yeah, you can get that. Okay. So, okay, when now you practice, and then when you finish, you tell me. Okay. And if you have any difficulty, you also tell me.
Oh, to make
Which part?
after we make the matrix A multiple by the parameter.
Okay. So first you create the matrix A, right? Do you have difficulty in making matrix A? No, right? It's just A is just 1, X and Y, and then parameter is anything that you set. Okay. After you calculate A, you can have A and P. You multiply Q equal to A times P. M volt. Okay. After that, you calculate D. D is sum square of distance, so you get the sum of the Q. Okay, after that you use solver. So I will show you. See, I have this regression in Excel. Right. So this is the data that we used earlier. So I will put here is yellow. Okay, using this data, you can calculate the slope and the intercept. Okay, so this is the intercept, and this is the slope. Right. After that, based on this slope and intercept, you can calculate the usual regression. Yeah. So you know the y of regression is the slope. Okay. X multiplied by the slope plus the intercept, right? Okay. And then what happened? We created, we want to do what is called orthogonal regression. So we create this matrix A. Okay. It is 1, and then this is the X, and then this is the Y. Okay. So, and then here you just put any number. Yeah? Say for example 111. Okay. So if you put 111 here, okay, and what you will do is multiply this one. Yeah? So this is the multiply of A with this parameter. So this is what we call E, Q. Yeah? Q equal to matrix A times parameter. Okay. After that, what you will do, you get the sum of square, yeah, of this. This is too much. So sum of square of this value. So the sum of square of the Q. So how to do sum of square of the Q? You just put sum SQ, yeah, sum square of this Q. Okay. Up to here is okay. Right. So of course you see the result is not really correct yet because these are not yet minimized, right? So our goal is to minimize this. So to minimize this subject to constraint, you see the constraint still 2, right? We want to do b square plus c square equal 1. So then you said, okay, I calculate this b square, okay, plus c square. Yeah. Okay, in this M7, I put the b square plus c square. Can you see that? Okay. So after that, what you will do, you go to the solver. Huh? So what you will do, you go to the solver. So you set objective is the D, okay, which is the sum square of the Q. Okay. And what you will do, you want to minimize, right? Minimize by changing the parameter. Okay. What is this parameter? ABC. Yeah? This is this parameter ABC. Okay. After that, you get the constraint, which is b square plus c square must be equal to 1. Okay? And then you solve. Okay. Oh, you get the solution. Okay. And this is almost 1, and this is the d. Okay. And this is the parameter. So you get that this result. Okay.
Okay, sir. Thank you.
Mm. Go.
I can find the solver, sir.
You cannot find the solver.
Yes.
The solver is in home. No, in is there any file?
File. Okay, file, and then,
Where is your file?
oh, I think, because I only shared the Excel, so the file tab cannot be seen.
The solver is supposed to be in data. Can you see it?
Here?
Okay, so you don't have it. So you need to go to option. Is there any option in your Excel?
Oh, wait.
This is marked, right?
Yes, sir.
Okay, so please check in Excel software in Mac. Go to Tools menu add-ins. In Mac, there at Excel add-ins. There. Okay, click OK. Now you have software.
Okay, thank you, sir.
Okay.
I will try to do it first.
You can just try. Okay. Anyone else want to share screen? Okay, so I want to show you something. Okay, solver in Excel is very sensitive to the initial condition. Okay, so if you put initial value, for example, I put initial value here 0, 0, 0, right? So and then solve. You get solution, but the solution is not really good. Okay, so you can see here the result. The D is actually 4 point something, right? Okay, but if the correct result is supposed to be something like this, no? So this one is supposed to be around negative 200. So if I put here negative 270, for example, initial value, yeah? And then this is 0, and this is minus 1, for example, this is close to the correct solution. Okay, and we solve it. Yeah. You see that the D is really minimized, and you see the line is actually very close to the actual, the linear regression and orthogonal regression are almost the same in this case. Yeah. So initial value matter, you know. The question is why, right? So the way Excel solver work is to do optimization is something like this. So, for example, this is the actual curve, okay, that you want to find the maximum, for example. Yeah? So, what is the actual maximum? Is actually here, right? But if your initial value is here, okay, what happens is it will start from this point, and then it will search, okay, around this point, and it will get the local maximum here and then trap there. Okay, so then it will give you this result rather than this result. You get it? So if your initial value is actually close to this global optimum, right? So say for example, you put it here, okay? So the Excel will search up to this point and then stop here. Okay? Then you will get the global optimum value. Okay, so the initial value matter because the way Excel doing is based on gradient, right? So gradient means the slope, okay, and then it will start the slope, okay, the largest slope until it become horizontal. Okay, when it reaches horizontal slope here, that means they reach the maximum. Of course, that maximum means local maximum. Is there any question? So if you finish this, okay, we can go to the next topic. It is model assessment. So tell me if you are ready. Okay. I will wait for you. Yes, go.
Wait, so for the solver, is it like this?
Okay, so what is O? O is,
Oh, wait, O is, wait, this one?
no, that is the constraint.
Oh,
You need to set up the objective is, in your case, R31, is it correct?
R, all this
What is the
one.
R31 here? Can you go to R31, escape first? Can you cancel first?
Wait,
Can you cancel? Can you cancel first? I want to see what is your D. Cancel.
wait. Why did cat? Mm,
So what is R31?
R31 is, oh, it's the D, sir.
Yeah, okay. So this is the one that you want to put as objective.
Oh, okay. And then for the constant will be
That one,
the
yes.
2.
That Q22 is the constraint.
Okay, okay. Wait, let me
Okay,
try.
let's do solve again.
Wait, let me reshare
Mm-mm.
because
Okay, so that objective is R31, which is the D. Yeah. Okay,
and then the changing variable will be this one.
correct, the parameter, that the three of them. P.
Okay.
And then that one is equal.
Oh, this one
Yes,
equal to 1.
correct. Okay.
And
Then,
then so,
yes, then solve. Okay, so there. Oh,
okay.
yes, click OK. But your D is very big.
Yes. I think it's the loading, sir.
Your D is very big. So probably the initial parameter value is the problematic.
Okay.
So this parameter you may want to change similar to the regression. Okay. In that regression, the parameter is what? Can you go down? There, 200. Oh,
At this one.
this one, one, 1965, and then the 7.2, right? The coefficient.
Oh, okay, okay.
Okay, so the A is around 1965, and then okay, so and then the P you can put any, and that one C is around 7 maybe. Okay, and then you solve again. Exactly. click solve. Click OK. Why why Q is not 1?
Oh,
Wait.
oh, it's equal 1.
Oh, no. This is wrong. Exactly. That's why it's not correct. This Q must be equal to Q, what is that? Q22, right? Sorry.
Yes.
Okay, can you close it first? Okay, go to Q22,
Q22.
then you put equal. So P28 square exponent plus P20.
C.
Yes. Okay, that one.
Ah,
Oh.
okay.
Okay.
Oh, I got it.
Okay. Now you solve it again. Ah. Okay. So this is
So,
very close, right? You see the parameter is very close to this coefficient.
oh, this one. This will be
Yes.
D.
Yes.
Okay. How about the graph, sir?
The
The graph.
okay. So very good question. So if you want to graph it, so uh, the y still the same, but the x you need to calculate. Okay, you use the same y, which is the data, right? So you can create x and y again, new chart, and then the x you need to calculate as based on this parameter. Can you calculate? So
Oh, wait. I'm clueless.
you are clueless. Okay, so what is the model? Ax plus a plus bx plus y equal 0, isn't it?
Yes.
Okay, type it there. A, can you
A.
a plus small a, right?
A plus
Plus bx plus cy equals 0. Now, if you know y and you know a, b, c, how do you get x?
Y.
You know a, b,
A.
and y, but you want to get x from that. Can you? So
We
that
need to know the C, right?
so then you can get right. Bx equal what? Minus c.
Px.
Oh, can you type?
Yes.
Okay, can you type
To
bx?
find the X. Px.
Yeah, bx equal
Well,
y over a, right? Yeah, minus cy over a divided by a, correct?
yes. Divided by 8?
Oh, sorry,
No, minus A, right?
minus a, correct.
Okay, so X will be
Equal cy
minus
over
CY.
b, no, cy over b divided, minus, right? Minus cy,
Yes.
minus cy over b divided by b, right? Minus a divided by b. Oh, now you get x. So you can calculate.
Oh, okay, sir.
Okay,
Let me try first.
right. The y
Thank you, sir.
data, right? The y is from the data. Now the x is the one that you uh, need to calculate there. And then you can
Oh,
plot.
we use the scatter or
Yeah, scatter. Scatter
okay.
is up to you. It's the same.
Okay. Thank you, sir.
Yes. Okay. So in the normal regression is the y that you predicted, right? So in here you reverse. Yeah? Is the,
Okay. So we create a new X and X. The Y is from the data, and then we create the X, and then we plot the graph.
and then you plot, yes.
Okay.
And then after you finish plotting, okay, uh, you don't need to change anything. You just change the data now. Okay, make it so that vertical line. The data is vertical.
Okay, okay.
Okay, and what happened if you put your data as vertical? Of course, the usual linear regression, yeah, simple linear regression, you cannot do, right? But orthogonal regression you can do. Right? That's the advantage of orthogonal regression. So, anyone else want to ask question? If you have difficulty, don't hesitate. Yeah, I admire Amira because she don't hesitate to ask. This is very good. Okay, and in fact, I encourage, right? If you ask question, you can claim your recitation point. Okay. Oh, and don't forget, if you claim recitation point, if you don't claim it, sayang ya, because recitation point is the one that can make you A. Okay. Without recitation point, even if you are getting all 100, you cannot get A. That's the design in this class. Okay, so please be active. Okay, so you want to go to bathroom. Okay, well, you're going, you can, I will stop first. So is there any question about orthogonal regression or regression in general? So you know how to use regression. Okay, so if you have finished this part, I will continue with the next lesson. So so regression is basically okay. This is just a summary. Yeah, that linear regression is actually provide the basis for other type of regression, right? So the function is linear in parameter, but not necessarily linear in variables. Okay, and you can see that you can use the same model, okay, for all type of this type of linear in parameter that not linear in variable, yeah, including the polynomial regression. Okay, so next point is I want to go to the next topic. Yeah, next big topic is actually supervised learning. So this is what makes the thing exciting in big data. Okay. What is this? This is basically the other name is classification. Okay. There are two types of supervised learning. Okay, so I will. So you can download WEKA. I hope you already downloaded WEKA, and I have sample data here that you can download also. Okay, and here is the link for the slide that we will discuss. So can you open your WEKA? Okay, so I'll clear my drawing. Can you see my screen?
Yes, sir.
Okay, so we have what is called supervised learning. Yeah? Supervised learning. Okay, so that one consists of two. Yeah? One is regression. Okay, and the other one is called classification. Classification. Okay, so what's the difference between regression and classification, and what is supervised learning? So we have also what is called unsupervised learning later. Yeah? Unsupervised learning. Okay. So Okay. As you see, okay, our model is actually y equal to function of x, right? With certain parameter alpha. Okay. So now, if your y here, your dependent variables, is actually, yeah, the y is quantitative, yeah, quantitative, yeah, then this is called regression. Yeah. If the y is qualitative, okay, that is mean this is regression, called classification. So what is quantitative again? Quantitative mean numeric. Yeah. So this one is either interval, okay, or ratio. Okay, data type. Qualitative. What is qualitative? This one is either ordinal, okay, or nominal. Yeah? So this is basically, sometimes we call this categorical. Yeah? Categorical data. Okay, so that including binary. Okay, so binary data is also qualitative. Yeah? I showed you a while ago that we can also use regression, but the result is not that good, right? So we need a specialized method for classification. Yeah. So why we separate into a big topic here with this classification? Okay? Because okay, when the dependent variable is actually qualitative, okay, ordinal or nominal, so categorical data. So suddenly you will be able to classify string. Suddenly you will be able to talk, okay, like natural language processing, right? Suddenly you can uh, discuss anything that actually label, okay? Not necessarily numbers, right? Because label is basically nominal data. Suddenly you can also discuss about preference, right? Satisfaction level, right? So you can also talk about, say, psychological level. Okay, so these are all qualitative data, right? So that's why this is a very important topic. In fact, because of this classification, so people start to join interest to what is called machine learning. So what is machine learning? So you make the machine can learn. What is the meaning of learning? Basically, when we said learning is just calibration, yeah. You will get the, if you have x and y, which is the data, right? Okay, the independent variable and dependent variables. Okay, so you want to get the parameter alpha. That is called learning. Okay, so why this is learning? Because by having this data that you have, okay, and then now you can get the parameter alpha, then of course after that you can put it here, and then you can predict, right? If you know the x, you can get the y, isn't it? So in supervised learning, this is exactly the one that you are just doing in regression. Yeah, you have the x, yeah, the input, and the y, which is the output, isn't it? So if you have that, that is called supervised learning. Either classification or regression, you need to have both x and y. Yeah? You need to have input and output. So the output here, the y, is called the teacher. Okay? Because you need to know the label for classification. So what is unsupervised learning? When you only have x, you don't have the y. Okay? And then you ask the machine, okay, to calculate the y. Okay? Of course, because the machine calculates the y based on certain distance, so it will not become the same as the supervised learning. Okay? So basically here is called clustering. Okay? So you will cluster the x, okay, into several categories Okay, so again, the Y must be categorical in this case, right? Supervised learning. So then you only have the X unsupervisedly. It calculates the distance and then you cluster them into different categories. That is unsupervised learning. Okay, is it clear or not up to this point? Any question? The bigger concept, okay, which is not in the slide. Okay, so with that, okay, let's try WEKA. Okay, so I hope you already open your WEKA. Here I have WEKA. Can you see? Okay, so what you will do is you open this Explorer. Okay, so now you can see here. This is WEKA Explorer. Okay, and then you can open the file. Yeah. Okay, so you can open the file. For my case, where did I put my file? Okay, so I will open my file here. It is in download. So I just downloaded from Moodle, which is the Lentera, okay, sample data here. Okay. And if you open that sample data, yeah, okay, so I will extract all. So I will put here extract. So here I got this example of files, okay, and this is already in ARFF file. This is WEKA file, okay, and the other are still in CSV. Okay, so let's do that. Okay, so we go to WEKA. Okay, open in download. Where can I get the download? No. Where is my download file? Anyway, if I cannot go up, one level up, download. Oh, here is the download, and then what is the name of available? Supervised RS. Oh, here, supervised, right? There, I got the transportation mode ARFF. I just open this, okay, and you will see here I have several variables. Okay, gender, okay, car ownership, travel cost, income level, transport mode. Okay, so every time you click this variable, you will see the statistic of that variable. Yeah. Okay, and clearly the class is transportation mode. Okay, this is the label that we want to do, and this is the X, this is the Y. Okay, the X is gender, car ownership, travel cost, and income. Yeah, and then the transportation mode is bus, train, and car. So based on the gender, car ownership, travel cost, and income level, we want to predict, okay, whether that person is using bus or train or car. Okay, so then we do classification here. Okay, so you choose whatever you want to do. Say I choose 3. Okay, say I will choose random forest. Okay, and cross validation 10. You just start. Oh, there. I got the result. Okay. So what is the result? Oh, I cannot see the result. Okay, the result is here 90% correct. Okay. But did not show the model. Okay, let me change the model. The one that can show random tree. Start. Oh, there. Okay, so random tree is better. So you see here, I got exactly the same. Okay, correctly classified instant is 90%. Right? So that is one install is incorrect. Okay. And then later I will discuss about all of this. So the most important part that you want to see is only this one. Correctly classified instant, that is 90%. So you get a very good result, right? And then here, this is the confusion matrix, okay? So it's pass, classified as pass is 4. Train classified as train is 2, and then have one wrong. Okay, this train is classified as pass. Okay, and then so if you want to see the confusion matrix, what you need to do is to check the diagonal. Okay, so this is the truth. Okay, out of diagonal is not correct. Okay, and then how you will use this model to predict, right? So here, this is the actual model, okay? So if your income level is low, okay, just select pass. Okay? If your income level is medium, then you ask the next question, whether the travel cost is cheap or standard or expensive, okay? If the travel cost is cheap, you ask again whether the gender is male or female. Okay? If female, use train. If male use pass. Okay? Now, if the income level is high, they will use car. So the random forest will create a tree. Okay, what is this tree? Tree is the rule. Amazing, isn't it? Okay, so you have the data. Okay, and the result is actually rule. Huh? The result is actually a rule. Okay, to classify. Okay, up to here. Can you try this first? And then you share your screen. Okay, each of you, you need to share your screen so that I will make sure that you are actually doing it. Okay, because this is very important. So who want to share screen? Okay, Lindsay.
Like this, sir?
This is the problem, yeah?
Yes, I
Zero.
already started.
Yeah, so you use rule 0. What is the meaning of rule 0? Rule 0 mean if you don't use any rule, okay, then you get 40% of correctly classified. Okay.
This one, yes.
Yes. Okay. So 40% is not good, right? So at least you need maybe 80% and above, right?
Yes.
Okay. So you choose.
Choose.
Okay, and then say you use trees.
Eh.
Oh no, trees. You click the arrow a while ago. That arrow.
Oh, this. Okay.
There you can get a random tree.
Random tree. Oh,
Okay.
wait.
Yeah, that's correct already. That's correct.
Oh, just,
Yes. You
yes.
click that, you can see here, there is can you see the name? Random.
Yeah. Random tree, this one,
And
yeah.
then you click start.
Start. Okay.
Oh, there you get. Okay, so you get 90%, right?
Correct.
this is the one that you need to understand, yeah, the confusion matrix.
This one.
Okay, so then go up. You
Go up.
there, here. This is the rule that you are using, yeah, to classify.
Oh, yes, random tree.
So that is the rule that you use to classify. Yeah? If the income level is low, okay, then use pass. Right? The two slash zero is that is the two instance of your data has been classified that way, right? And then if your income level is medium, then you ask the next question. Yeah. If the income level is low, don't ask the question. Just directly, or they will use pass. Yeah. So if income level is medium, you use the next question is where travel costs.
Yes.
Okay. And then if the travel cost is cheap, then you ask the next question, which is gender. Right.
Right.
But
So
if you look at
what is the meaning of 2/0?
that is the number of instances that classify that way.
Oh, okay, sir.
So the number of instances, the number of rows. Instances mean rows. Your data consists of only 10 rows.
Oh, okay, sir.
Okay.
So second row, yeah.
No, not second row.
Huh?
Rows. 2 rows.
Oh, 2 rows. Okay.
Okay. So the total should be 10.
Yeah.
Is it clear?
Yes.
Now you can try other things. Yeah. You can choose here, and then say function here, for example.
This, yes.
You can have this one is a neural network. Multi-layer perceptron is neural network. Okay. So
Yeah.
you start again. Oh, you get 8%.
80%.
Oh, you are using neural network already. Wow. Right?
Yes.
Very nice, right? So if you use neural network, you get 80%. And how are you going to use that neural network? Go up, yeah? Go up to that there. This is the model, yeah.
Yes.
Maybe next meeting I will discuss about neural network, yeah. The model here. Okay. This is the one that you will use these numbers, okay, to predict. Okay.
Okay.
So at this point, what you need to do is to check the going down.
Check the
Accuracy, correctly classified, 80%. 80% is acceptable, right? And then
this one.
confusion matrix. Yeah? You check the confusion matrix here. The result is actually what is the wrong part there. The wrong part is actually train classified as pass, right? There are 2 instances here. This is the wrong part. Yeah? Train classified as pass, this one.
Yes.
Okay, the others are in the diagonal incorrect. Yeah? So you can try any other method to classify. Yeah, and then look, WEKA also have clustering. That mean this one is unsupervised, and also have associate, meaning that this is for a market basket analysis, yeah, using a priori. So yeah, there are many methods in here. I think 100 of them. I don't discuss one by one, but you can try on your own. Huh? So can you make it so that 100% this one correctly classify?
What, sir?
Can you try other method so that the correctly classified instant is 100%?
What method? What you want, sir?
I don't know. What do you want? Not what I.
Oh, no, sir.
Okay, there are many methods there, so you can select. Okay.
Yes.
Okay. So is it clear and everyone? Okay. Now Who want to share screen?
Okay. Stop here.
Yeah.
Sir, can I share my screen?
Sure, you. Okay, so you get that classify. So this is your data, the statistic of the data. Okay. Go to classify. Okay, and then choose. What do you want to choose? I suggest trees. Yeah, that is the easiest. Okay. The tree. You go to the arrow that click, and then you can choose J48. Try. Okay, and then start. Click the start. Oh, there. Oh, the J48 prune is very simple. No, not really tree. Yeah? They just use it based on travel cost, right? If the travel cost is cheap, use pass. If the travel cost is standard, use train, and then if the travel cost is expensive, use car. Using that method alone, you get 95%. Okay. Using that rule alone, you can get 95%. 90%. Yeah. That correctly classified 90%. And what is missing? That is train is classified as past there. Down in the confusion matrix. Okay, you choose other method. Okay. So you select other method. Say Bayesian, for example, naive Bayes. What will happen if you use naive Bayes?
Which one, sir? Sorry.
Naive Bayes. You can try naive Bayes. Try in Bayes. There is a naive Bayes. Oh, not so good, right? You get only 50%. Okay, so forget about it. Right. So then you try, okay, using this WEKA, you can try many methods so that you can get the highest percentage. Okay, so I don't know which one will give you a highest percentage. Okay, so just choose, okay, what method you can choose. There are many methods there.
Okay, thank you, sir.
Clear, yeah? Is it clear or not, this one? Oh, come on, Eunice.
I cannot open the file.
Oh, you cannot open the file. Oh,
Yeah.
which file you don't open? You open the ARFF file.
Yeah, and then
Share your
That-
screen so I can help you. Come on.
okay, wait. This one, yeah.
Okay, open the file.
And then like this.
Go to open file. Well,
Open file. This one, right?
I cannot see your. Can you share whole screen so that I can see?
Okay, wait.
Oh, because you open using CSV. Wait, cancel it first. Cancel it first. Open file. Click. Where? Oh, click.
Click.
Double click.
Oh,
No, go inside. That is okay, that one, transportation. Open.
oh,
You
okay.
and then classify.
Where is classified?
There, menu classify. Can you go to menu classify here?
Oh,
Yeah. And then choose. Yeah, choose. Okay, so everyone choose trees. Here, click this arrow.
this one, start.
Oh, what is your choose? You did not choose yet. Choose.
Loh. Oh, loh, why
Open that
cannot?
arrow. Don't select zero. Here, this. Click this. The one I put in the red.
Why cannot?
Can.
Oh,
There. Hey, you choose random 3.
loh, close again.
Yeah, you choose already that one. Click. Okay, and then you can see here, if you have chosen, you can see this result. Okay, and then you click start.
Okay.
Then,
Mm.
okay, so this is the 90%, this is the confusion matrix, and this is your 3. Okay,
Okay.
clear?
Yes, sir. Thank you.
Yes, okay, very good. Okay, so who else? Netanya.
I'm lost,
Everyone.
sir.
Eh?
I'm lost.
You get lost. Did you download?
Yes, already.
Okay, you share your screen then.
This one.
All right,
Explore.
correct. Can you share the whole screen so that I can help you? This is only.
Oh, already.
Okay, very
Share my
good. So
whole
open
screen.
file. Yes, open file. Oh, where did you download your data file?
Wait, sir. That,
Data file. The data file you download from Lentera. Did you?
what data file, sir?
This one. Go to Lentera. There is a sample data here. Can you see my screen?
Ah, yes.
Okay. Okay, sample data. Okay, this one that you download and then you unzip. Okay, so while Netanya is unzipping, so who else want to share screen? Eunice finish, Lindsay finish. Who else? Saint Patrick. Oh, come on.
Okay, sir, I'll share my screen.
Oh. Even if you don't know anything, at least this WEKA should know how to do, right? And then at least you will say, okay, at least I learned WEKA. Oh, you did. Okay, very good. What? Wow. Okay? Which one is the best model so far?
So you're asking us to find.
Yeah, the highest correctly classified
Yeah. So basically, I've tried several. What is this?
method. Yeah,
Yeah, several method, but I couldn't seem to find any higher number than 90 so far.
Oh yeah. Okay, so you cannot get higher number than 90. Okay, so.
So, sir, basically, what is this one percentage?
Oh no. Later I will. You use cross validation 10.
Oh, so still cross validation, right? Oh,
Yes.
yes, sir.
And then start. Okay.
Yep.
So I will discuss about that test option later. Huh? In the model assessment later I will discuss. Okay. So first I want to make sure everyone is okay using WEKA. That is the first task I need to make sure. Okay. Thank you, Sin. Yeah. Axel.
Wait, sir, I'm still downloading the sample files.
Okay. So who is ready? Come on. Ken Jordan. Disappear. Stephanie. Are you still there, Stephanie? Josephine, are you there?
Yes, sir.
Okay, can you share your screen?
Okay.
Okay, so you did it. Very good. Okay. Okay. So what is the best so far you got?
I think this one, sir.
This one is 80.
Yes.
Not enough, no? A while ago, I can show you that I can get 90. So you try other method that make it at least 90. Okay,
Okay, sir.
use other method. Okay. Actually, you can get 100% this one. You know? Okay. So who else? Come on. Valencia Deora. Oh, you did. Very good. Oh, you got 90 already. Very good. Oh. So, do you know how to interpret? Do you know how to predict also?
No, sir.
Oh, go up, go up.
What?
Go up a little bit. Here.
Oh.
Oh, there. Yo, if you use J48 is what you will use. Okay. Just check using default cost. Okay.
Okay, sir.
Try this one, random tree, so that is clearer. Okay, so if you use random tree, go up a little bit. There. This is the one that you use. Do you understand the meaning?
If the income level is low, they use bus and stuff like
Correct.
that. Right?
Okay, no need to remember the number. The rule only you need to get the rule. Okay, this is the one that you use to predict.
Yes, sir.
Okay, so at least you know method.
Yeah.
This is very good, no? And I want you to know how to predict, how to train. That is the important part. And of you can select whatever in here. Okay,
Yes.
you can read all the other method also. Okay, but at least one. Very good. Okay. So who else? Come on, Janice. Are you there?
Wait, sir, I'm still downloading the sample data.
Okay, Jonathan Pinotto. Are you there? No, you're not there. Oh, Josephine, you removed the name of Jonathan Pinotto. It's just Michelle, Angelina.
Yes, sir.
You share your screen.
Oh, wait. This is,
Yeah, the
I
Explorer.
still search 100.
Eh? Search what?
This percentage.
Explorer. You go to Explorer.
Yes.
You click this Explorer. You download the data.
Yes.
Okay. So you click that Explorer. Can you share the whole screen? Because there you get it. Okay. So you classify. Can you classify?
This is, I think, I try
What?
I try another method.
Yeah, you try another method.
Yes.
So
This is,
try classify. Can you click this? Classify.
This is like this.
I cannot see. Oh, can you share the whole screen? I cannot see.
Yes, I share.
Did you classify?
Yes. Can you see my screen?
No, I cannot see your screen.
Oh, I don't know.
Oh, there, I can see. Okay. I think because you did not share the whole screen. There, okay.
Yeah.
That one. So, okay. So try to understand the meaning of that. Can you?
I try, sir.
Can you explain?
I only know this is.
Can you share that screen?
I share.
No, because this is what you share is only the main WEKA GUI chooser.
Wait, I am confused, sir.
If you can you share the whole screen?
Like this.
Yeah, okay, this one. Very good. So this is the one that you need to check, okay?
Okay, sir.
This one, and this is how you will predict. Okay, very good. Okay.
Yes, thank you, sir.
All of this, which one is the best?
I only get the three, the best, I think.
So you need to record, okay, which one is the best.
Yeah.
Okay. Okay, who else? Thank you.
Thank you, sir.
Yeah, Michelle. So who else want to share? Who did not share? Amira, did you share?
Not yet for the WEKA. Yeah, let
Oh,
me
cool.
share it.
Okay, very good. You already tried several, huh? Okay, very good.
Yes.
Amira. Okay, Karin.
Already, sir, just now.
Oh, okay, you did. Okay. So who did not share? Yenny, Chandra.
Yes, sir.
Can you share your screen?
I can't share my screen, sir. Wait. I'm trying. Okay, no, I cannot share it.
You have a technical difficulty?
Yes, sir.
Okay. So who else want to share screen?
Let me, sir.
Okay, cool. Accept. Wow.
Do you see my screen?
Very good. So you use already several things, huh? Very good.
Yes, sir.
Okay, so go down to the 80%, eh? This one, eh? And then confusion matrix, that one. The same, yeah. Apparently the difficulty is to for the train. Yeah? It always
Yes, sir.
as pass. Okay. So who can get 100%? Can you show? You will get you can claim one more recitation if you can get 100%. Anyone? Jonathan, you want to share your screen?
Sorry, sir. I just download the WEKA, sir. Initiate.
Download it.
I just download the WEKA and not finish yet.
Okay. Okay, so for your group project, so you can try to use WEKA and then connect it to your, if you use Python, you can use scikit-learn is the same, but you need to code it. In WEKA, you don't need to code, right? You just click. So you can also use the WEKA if you want. Huh? Okay, so now I want to share my screen. About WEKA. Okay, so this is the lab session you already learned. Okay, so I already explained to you, okay, how to create different data representation. Okay, after this I will explain to you how to check the data, and then interpret the result, and then you need to compare to find the optimal classifier. Okay, I will not discuss the theory behind each method in WEKA. Okay, so WEKA is basically machine learning environment in Java. So it has several applications. What you need to use is only the Explorer. Okay. So it's written by these two authors. Okay. And it has a graphical user interface, including data visualization. And then you can compare many methods, many algorithms. Okay. And then it has also pre-processing tool and learning algorithm and evaluation method, right? Okay, so this is what actually your data. Yeah? The data consists of gender, car ownership, travel cost, income level, and transportation mode, right? So gender is either male or female, right? Car ownership is 0, 1, 2, 2 until maximum 2. And then travel cost is either cheap or standard or expensive, right? And then what is this? The income level is low, medium, and high. Okay, so you see all of this except the car ownership is actually categorical data, isn't it? Okay, so then what you need to do, actually, I did it for you, but what you need to do is, if you have this kind of data, okay, similar to your group project, right? Your data is something like this. So what you will do is to create what is called ARFF, okay? So say you have your data in spreadsheet, or if you have your data in spreadsheet, okay, save it as CSV. Yeah? Your data should be something like this, okay? Comma separated, yeah? And then after that, okay, you need to add relation name, okay, and then you need to add the attribute and the value, okay. If your attribute is numeric, you can put as numeric, okay. If your attribute is actually categorical, you need to specify the value, okay, of each category, and then you add data, okay, and then optionally you can add comment using %, okay. So here is example. So first, add relation. So this is the model name. Yeah. So for example, the model name is heart disease simplified. Okay. No space. So that's why you use does in here. Okay. And then attribute means the variable. So the variable name is age. And then what is the data type? Okay. Numeric. And then the second attribute is sex. Okay, what is the, because this is nominal, so you need to specify the value, which is female and male. Okay, and then the attribute is, for example, the name variable is chest pain type. Okay, there are several possible values that you need to put in. Yeah? The same thing here, say attribute is numeric, cholesterol, yeah, Is numeric exercise induce enigma, yes or no, and then class is present or not present. Okay, and then you can put all the data, and this data must be exactly in the same as this order. Yeah? Okay. So let's see my data. Okay. So I can put percentage here. That this means this is comment. Okay. So I have three attributes. For example, x1, x2, x3, and then the y. This is the class. Okay. I want to know whether this is actually 0 to 9. Yeah. This is the numbers. Okay. And these are my data. Okay. Many actually. Yeah. So a while ago, okay, inside that ARRF is when you right click and then open it using text file or notepad, you will see exactly this one. This is the exact data inside that file. Yeah. So I put relation is the transportation mode, and then I have how many variable? 1, 2, 3, 4 variable, and then this is the class. Yeah. The class is the transportation mode. Usually the class you put in the end. Yeah. So the car ownership is numeric, while the others are nominal, right? So I put it this way, okay? And this is the data. So you put the data, you compare this with a while ago, yeah? The actual data is something like this, right? So this is the whole data, okay? And this is the variable name, right? So in the variable name, you need to type, okay? Something like this. Okay, attribute gender, and then what is the values. So, okay, so for your practice, okay, so after you get that ARFF file, okay, and then what you will do is go to classify, and then okay, select the cross validation option, so either 5 to 10 fold, and then start. Okay, that's it, right? So this is just a graphical user interface. Right? This is what you did. Yeah. So, and this is the random forest a while ago, right? And what you need to see is only the correctly classified instance, okay, and then the confusion matrix, okay. And of course, you will have a lot of method, okay. So what you need to do is to check the confusion matrix, okay, and then record the percent correctly classified. Optionally, you can also add the root relative square error. Okay. If your data is very big, this is for your group project. Okay. Sometimes if your data is very big, okay, this will have a problem. So if this problem, it will have an out of memory problem. It will create error. Okay. So if you do that, okay, if it happened to you, you change the heap memory of the ini file of WEKA. So in my case, I have this is the name. Yeah? So you open it. This is just a text file. Okay. And you can check also this how to increase the heap file in WEKA. Okay. So for your group project, this may have help you in solution. So, and you can have many data representation, and then you think of idea how to improve so that you can get 100% correctly classified. Okay. So these are the example of model that you can use. Okay. And this is example of my other data, yeah, not transportation. So I have you see the first time I get only very low. Yeah? You see it's 15%, 14%, yeah, using my data. Yeah? And then I change the data representation into second one. Again, this is very low. Yeah? Maximum is 18%. Okay. And then I change it into another data representation. I get 100% classified. Yeah? Some methods still 20%. Okay. So, and if I use root relative square error. This is the result, okay, for the same data. Okay, so one way to do is to increase the image copy. Okay. Why? Because WEKA sometimes, if you have only one data, it's been only 1 point for them, so you cannot get it. Okay. So what you need to do is actually to improve the repetition. Okay, you can improve the repetition of the data. Okay, so that it will improve, become 100%. Yeah. So okay, I will share my screen to you. WEKA again. The whole screen. Can you see? Oh, what happened? Can you share? Can you see my screen?
Yes, sir.
Okay, so you go to pre-process. Okay, and then you choose the filter here for supervised learning, right? So this is to discretize, you don't need that. Instance. Oh, here it is. So you choose resample, okay? This is the explanation, so you choose resample. Supervised instant resample. Okay. So I resample 100%, 100 times, isn't it? Okay. And apply. Yeah. So look at the number of instance is 10, right? In here, can you see? So this is 10 data only. So I apply up to 100. Okay. So I increase the number of sample, and then I classify using the same, yeah. So I use random forest again. Oh, I get 100%. Can you see it? Using random tree, yeah. Now let's try using random forest. What I get? Oh, again, random forest, I get 100%. Yeah. So you resample, you increase the number of sample. Okay. So then you can get 100%. Okay, so I give you the trick how to solve your problem. So that's it for WEKA. So question? Can you make it 100% now? Anyone want to share screen? Oh, you got 100%. Very good. Yeah. Easy, right? Oh, you get 100%. Right. Correctly classified. Yeah. Okay. Very good. Very good. Okay. You can also copy. Yeah. You can also copy the data 2 times, 3 times. Yeah. Same data repetition. Okay. Okay. So you got that. Is there any question about WEKA? I hope you enjoy this. So you can already do a classification, right? Any question? So you are ready for your group project presentation, yeah? With this, you can continue, right? So the difficulty, if you are 100, so you need 100 variables, right? With the name, so you need to do it, yeah? So now I want you to practice, okay? I want you to practice what I want you to practice. I have a by computer, mammal 2, and transportation mode, right? in the data that you downloaded, the sample data, right? So now for biocomputer mammal 2, can you create the ARFF file and then you get the same thing, okay? Or mammal, okay, try mammal. Mammal is difficult. Oh. Can you open mammal? Mammal data file. Okay. So right. So this is the, if you open, you will see this. Right. So is it give birth? Yes or no, right? Lay egg? Yes or no. Yeah? Can fly? Yes or no. Live in water? Yes or no. Have leg? Yes or no. And then this is the class. Okay? So if yes, no, 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 yes, it will become mammal. Yeah. Otherwise, reptile. Yeah. Yeah. Reptile do not give birth, right? It lay egg. Yeah. And then can fly? No. Live in water? No. Have leg? No. So it's reptile. So these are the actual name of animal, actually supposed to be. Okay. This is the class of the certain animal. Yeah. So based on this data, okay, then you're supposed to predict the class. Okay. The same thing, yeah. So by computer, can you see? So what is the age? Yeah? The age is old, young, or middle age. Okay, the income is low, medium, high, whether this is student or not. And then what is the credit rating? Okay, and then based on these 4 variables, whether that person will buy a computer, yes or no. Yeah. This is the way to do. Now, I want you to create from this CSV data into, you convert it into ARFF. Yeah. Okay. So, okay, you practice this, and then once you finish, you open the ARFF data that you put into WEKA. Okay. After that, you share screen. Okay, go. Okay, so this is the mammal. Okay, so you get it in CSV, right? So how do you create ARFF out of this? Do you know?
I'm not sure, sir.
Huh?
Not sure.
Not sure. Okay, so can you close this one? Okay. No, no, you share your whole screen and then close that one. Karin.
Oh yes, wait, sir. Wait a minute.
Close unnecessary things and then share the whole screen. Do you have Notepad?
Notepad.
Text editor. Yeah, text editor.
I don't think so, sir.
Of course you have.
Hey, wait, I don't know.
Okay, okay. Oh, yeah, share your screen so that I can help you.
Okay, sir. Share my whole screen.
Your whole screen. Because I really need to. No, you can close this one.
The Excel.
Excel. You can close the Excel. Because if you don't close, you cannot. Okay.
Oh, wait, sir. Okay.
Okay, can you open that file a while ago using text file? How do you open using text file? in Mac text file, Mac text editor. Mac text editor.
Oh, wait a minute, sir. Let
Text
me.
edit is your default, right? Text edit.
Oh, yeah, text edit. Yeah, yeah, yeah.
Okay, can you open using text edit?
Yes, yes. Like this, yes, sir.
Ah, very good. Okay, so then you save as this one. You save as.
Oh, yes. Okay, wait. Save as.
Save as mamal.arff.
Oh, wait, sir. Let me. Like this, right? And then.
Is there any way to save as?
Only save, sir.
Save only, you cannot save as?
Cannot. Wait. I don't think so, sir. Or maybe refer to, yeah.
Wait, I will. What is the? You are using text edit. Text.
Yes, correct, sir.
Mark. Save as. Okay, launch text edit. So there is save. In the save dialog, you can have extension. Save. There is a dialog, right? When you save.
This one is the save one, right, sir?
Yeah. You click that one. Is there any dialog?
No.
No. Supposed to be. Because I'm not using.
Maybe refer to, yeah. Oh no.
When I search in Google, it says go to save, press Command S in the save dialog box, and then you can save as. In the format, there. In the format menu, choose plain text and then save as. Okay, if you are using Mac, Karin, you can share your screen again. Is there any format? And then make plain text. Make plain text. Make rich text. Is that there is no make? Or you? No, this one is RTF only. Is there any way to? Mac is very peculiar. There is no way you can save as.
I don't know, sir. I'm confused why there is no option, yeah.
I don't know why you have no option for that. If you don't have option, then you can probably use other text editor. Can you download Sublime Text, for example? Is it possible to download other text editor?
Okay, sir. Let me try.
Can you download Sublime Text 3? Okay, if you are using Mac, and you cannot save as. So probably you can download other text editor that provides save as. Okay. Basically, what you need to do is just save as ARFF, okay, and then you put add relation, add attribute, and then add data. Okay. Anyone use Windows?
Me, sir.
No, go.
Okay, wait. Do you see it?
Yeah, so, okay.
Yeah, just save as,
Yes, and then save.
save.
Yes.
Okay,
Okay, already done. So you open that now using a notepad, you can open that. Now you can add relation. What is
here, sir.
relation? No, yeah, on the top, yeah. Add relation. Okay, any name that you want. Okay, for example, mammal. Space.
Wait, it's using space. Using
Yes,
space
yes.
or no, sir?
Space.
Here, sir.
Okay. Okay. Okay, bird. Okay, and then next. No, it's relation, so no need to put. And then next row. Enter. What? You have, what do you have there? Give birth, right? So attribute, add attribute. Okay, give birth. Give birth using dash or underscore. No.
Wait.
Okay, and then what is this? Yes and no, right? So you put
this one or this one?
Bracket, yeah, curly bracket. Okay, yes, no, comma, no. Close it. Okay, next. Lay eggs, right? Attribute lay eggs. Actually, you can use that this row, and then you just add attribute, copy.
Oh, okay, sir. Right, let me put this.
Yeah, and then the same, right? That one is copy, right? The next one is can fly, right? The same. And then live in water. Again, yes, no. And then have leg. Again, yes, no. And then attribute again, class, right? Class.
Oh, yes.
Okay, so you need to type all the classes. Mammals, reptile, fishes, amphibian. So that will not have wrong spelling. Your mammal is wrong spelling.
Oh, yes.
Comma, reptile, and then fishes, comma, yeah. And then amphibian, yeah. And then what else? Bird.
Birds.
Reptile already there. What else?
What else? Oh, there's no.
Down. Oh,
That's all.
Right? Is that all? Okay. And then add data.
Sorry, sir. What?
One more. Enter and then add data.
Add data.
No. Add data. Okay, so this row you just remove, or you can put percentage. That's fine.
Where this row?
No, only that row.
Oh, okay. Right, let me just put percentage.
Just put percent. Ah, okay, very good. So then you save.
Save.
This is on in RAF already, right?
I think so.
Okay.
Wait.
Then you open using WEKA now. Try. Where did you put that? Oh, there. Okay, open. Normal. Oh, there is something not correct.
Is it because I put this here?
Not declared. Nominal value not declared in header. There is line 14. Okay, click OK. Okay, again, check your data. See,
Yeah.
there are some things that not there. Line 14 in your data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Feces already. 11, 12, 13, 14. Feces. Normal bird. Is it? Oh, there. Sometimes you did not put sometimes.
Oh, okay. Right. Which one is it?
Yeah. 1, 2, 3, 4. Number 4.
Right. With avatars sometimes. With avatars. Oh. Sometimes.
Ah, okay. Save it again and then open.
Okay.
Perfect. Now you can classify.
Missing trees, right, sir?
It's up to you. You select so that you will get 100%. Okay.
Okay. So I stop
Oh,
sharing.
this is like 65%. So it's lower. So you need to try so that it become 100%. Huh?
Okay, sir.
Okay, very good. So now you know already, right, how to create from your data file, okay, for your project, you know how to create ARFF, right?
Yes, sir.
Oh, so once you know how to create ARFF without error, then the next is just click. So easy.
Yes, sir.
Cool. Good. So anyone else want to show your work? The one in Apple, in Mac, a while ago. Karin,
Yes, sir.
were you able to?
Still trying. Wait, before you said download what app, sir?
Not WhatsApp. Sublime Text. This one. Can you see? This is Sublime Text. And then from here you can file, save as. Right? So this is a text editor similar. So Sublime Text 3. So anyone else want to share screen? I want you to make sure that you can do it.
There, if I just open
Ah,
using CS
Amira.
in WEKA, is it okay?
Ah,
Like this.
okay. Oh, you can directly open in WEKA. Oh,
Yes, using the CSF.
okay, using the CSV.
Oh yeah, CSV.
Okay, very good.
Okay.
Okay, very good. So can you try also for manual and by computer? Can you also try? Can you get 100%? Oh, Karin, she said you can try directly without ARFF, directly in CSV, in WEKA. Just convert. So, everyone please try, okay, so that you will know.
There previously, if the data is very big, how can we use the WEKA?
It's the same. There is no difference.
So we can directly like insert the CSV file.
CSV file. CSV is just comma delimited file, right?
Okay.
Okay. Why don't
So
you?
it's okay if the data is really big to the WEKA?
If the
Okay.
memory have problems, so you need to increase the heap memory.
How to use the heap?
How to change the heap? So you go to runwayk.ini. I don't know in Mac where it is. In Windows, there is a program file, and then what is the name of WEKA? Then you can check. The runwayk.ini. Okay, so the heap size is actually the memory that used by WEKA. Of course, if your computer cannot open, then WEKA cannot open, right? So if your data is really, really very big, your computer cannot open. So then of course WEKA cannot open. But if your text file can open, WEKA can open also.
Sir, what is the maximum size for the data, sir?
There is
Like,
no maximum size. The maximum size depends on your hardware.
oh. Okay. So is it like this, yeah, sir?
Yeah, so this is Sublime Text Correct. Very good. So save as. The TXT you change to RFF. ARFF.
ARFF, like this, sir.
Yes, save. Very good. So now you have it. Now you need to change the at relation and so on. Okay.
Wait, sir. How to do it, sir?
Oh, you just type at relation.
Where, sir?
There, in line 1.
Oh, in line 1. At relation like this.
Yeah, and then what is the name? Relation that you want. Karin, the name relation is Karin. Enter.
Oh, like this.
Between relation and the name of the relation, so you keep space.
Oh, like this.
And then the next line, add attribute.
In second line.
Yes, second line, add attribute. And then that one is actually, you just copy that add attribute to how many times? All this give birth, lay egg, can fly, live in water, have leg, and class. These are all attributes, so you need to specify one by one.
So, wait, sir. Add attribute in second line, and then?
So what is the name of attribute? The first column of your data, what is that? That is give birth, right?
Yes, yes.
So you copy that.
Copy give birth.
there, and then put in the after attribute.
Like this.
Okay, but the problem is that one have space, so you need to put dash so that dash or underscore is fine. Give and bird, between give and bird you need to put.
Like this, sir.
Okay, yeah. And then you put the value. What is the give bird value? Yes and no only, right? So you put
Yes.
Curly bracket. Okay.
Yes.
Curly bracket. Yeah.
Oh, wait, which one?
Yeah, correct. That's correct.
This one.
Yeah, and then yes and no.
Yes, no. Like this.
Or comma.
Yes, comma, no.
And then next, what is the next attribute?
Lay X.
Yeah. Okay, so continue like that. Just copy that and then change the name of the attribute.
Lay X, yes, no.
Yes, no.
Yes, right, sir.
Can you keep space between the name of the variable and the value?
The name of the variable and what, sir?
The value is yes, no, right? So
Like this.
yes.
And then
what is that?
can fly.
Okay,
Can
space.
fly, yes, no.
Yeah, keep space. Okay. And then live in water.
So live underscore in underscore water, yes, sir.
And then what is that?
Have legs. Have
Okay. And then class.
Oh, for the class.
And for the class, you need to put one unique value. So you copy that one. Mammals, reptiles.
Mammals.
Copy na. So that
Reptiles. Fishes.
amphibian. Birds.
Like this, sir.
Yes. And then add data.
I'm sorry, sir?
Add
data.
Yeah, okay. So that line number 9, you put percent in the beginning so that become comment. Okay. I think you have some times there, right? 1, 2, 3, 4. 1, 2, 3, 4. So live in water is sometimes, isn't it? There's value of sometimes in the fourth variable.
Live in water. Yes. Oh yeah, sometimes. Oh yeah, wait, sir. Sometimes like this, yes, sir.
Yeah. Okay. So save. And open it in WEKA.
Okay.
Okay. Save. Control S. And then now you open in WEKA.
Okay, wait, sir.
No error, then okay. So have error. What is the error name?
Wait, like this, right? The way.
Open file, yeah.
Open file.
Where is that?
Wait, sir.
ARFF.
Is it in download too?
Where did you save?
Hey, wait, sir. Let me search for the file, yeah.
Or you can move it. You can move that file into the same as the transportation mode. Or you can save as. Okay, the others, can you do? Everyone, Jonathan Pinotto. So is it. Valencia. Janice. Oh, okay.
Wait, sir. Like this, yes, sir.
Yeah, it works, so no problem. So you just classify then. Oh, you got 100?
Oh, no. That one is the last one, sir. Yeah. wait, sir. Oh, this one is before the.
Oh, before. Okay. So,
Yeah, before. So
you
use
just, it's okay. Any.
random forest.
Okay, so start.
Oh,
50.
why 50? Yeah.
Not yet. So you try so that you can get 100, huh?
Oh, maybe. Oh, wait. Use filter lah, sir.
Huh?
No, yeah.
I think you already filtered that. No? Or you apply.
Oh, wait. Choose attribute.
Instant resample. That one you already choose.
Oh, yeah. Resample.
Apply.
This one, yeah, sir.
Yeah, you did not
Apply.
apply. Okay. And
then.
start. Ah, getting worse.
Oh, no. Is there something wrong with my data, sir?
No.
Why cannot 100%?
This is really difficult problem.
Yes.
Mammal is one of the difficult problem in classification. So okay, even though data is not so much, but this is quite difficult to get 100%. So this is the challenge. Okay, so try. So my point here is just so that you can create the ARFF data. That is the important point. So once you can do that, and WEKA is just to use, okay, selecting the options there. It is not so a big deal, right? Okay, so who else? Want to share screen? I think time is not enough. So, okay, so I will let you read this slide, okay? Next meeting, we will discuss about this. Okay, can you read this slide? Model assessment, okay? And then we also will discuss about this one, classification and decision tree and neural network. If you read beforehand, okay, this one, model assessment, this is classification, discriminant analysis, decision tree, and neural network. Can you read all these 4 files, okay, so that we can finish next meeting. Can you see?
Yes, sir. Yes.
Okay, so I guess today is until here, but if you want to share your screen, so go ahead. And if you have any problem, to tell me.
Share screen WEKA, sir.
Go.
Okay, sir. This one, sir.
Oh, very good. Okay, so you can open it, classify.
Classify.
Okay, using 40%.
Yes. Because oh yes, sir, I want to ask about this. What is the sample size percent? Why it lower than?
You increase say 1,000.
Yeah.
Okay.
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 Then I can same.
Same. Okay, you choose different method. Choose different method. Classifier. Choose different classifier.
Okay.
Maybe you use naive Bayes.
Naive Bayes.
Bayes. Top.
Where is naive Bayes?
Bayes is the in
Oh,
Bayes.
naive Bayes. Okay. 35.
Oh, that's even worse. Okay.
Yes.
Try.
What are those number implied, sir? Like For what?
Which one? This is the
This 1000.
you increase the number of sample,
Oh.
right? It seems like you sample you can also put the okay, this is not this one.
If what's that?
This is the you sampling, you sample from the actual data, you resample.
Oh, okay, sir. Okay. Okay.
You resample.
Yes.
Okay, so you get worse actually.
Yes.
Okay, so without resample, no resample, what you get actually better.
Yes.
Oh, okay.
I think so. Or is it the same? Maybe. Yes, the same, sir.
Same. Okay, so maybe you just choose other method.
Mm,
How about function? In function, there is a multi-layer perceptron.
okay. Same.
Same.
55. Okay.
Okay, so yeah, this is hard problem.
Yes. Okay.
Yeah. Using my method, because I developed my own method, right? Using IFN, I think I get 89 only.
Oh.
Yeah. So I cannot get 100% for Mama. Okay. For other method, I can get 100%, but Mama I cannot get. So this is really hard.
Yes.
So I get only 89 for.
Yes, sir.
Okay, but not WEKA, yeah, using my own program. So using my own.
Oh.
So.
Okay.
Okay, using IFN that one, using an ideal flow network. Okay, so okay, with this, I hope you can create at least, yeah, for your group project at least 80% lah.
Okay, sir.
You're supposed to be able to. So one other technique that you can you open your screen? Okay, you can also copy the whole data set. You can copy 2 times. Okay, Lindsay, can you try?
What, sir?
Open. Do you have a notepad or?
WordPad.
Yeah, for WordPad.
Okay.
Can you open the ARFF file of your
Of the mammals. Or
your ARFF file?
ARFF file.
Can you share your screen so that others can also see your work?
It's loading.
Okay. So without resampling, yeah.
Oh, but I haven't convert, sir. Is it like?
Oh, that
Yeah,
is
because I convert like directly using
directly.
WEKA.
Oh.
Yeah, so my.
Oh, you still use this.
Oh, yes.
If you use this, no problem. So copy this, the second row until the end.
Second row until the end.
Okay, Control C.
Yeah.
And then you put down here at the end of the file, then Control V, right?
This one.
Okay, so remove that space in between.
Okay.
Okay, now you save it. Now you have 20 data, huh?
Save directly, sir. Or save.
Yeah, save.
Okay.
Okay, open again in WEKA. So a while ago was 35, right?
Yes.
Okay, so you use the same method, but the new data. How many percent now?
Wait,
Does it
okay.
improve or not? Can you share your screen?
Oh, wait, sir. I think it is pause. Share screen. Okay.
Okay, now you have 20, right? Use the same method as a while ago. The one that, how much a while ago?
Ro-
Say, okay, say, click OK.
65.
Oh, increase, right?
English, yes.
So that, if you repeat your number of data, it will increase.
Yes. So the bigger the sample, it is
Better.
better, yeah.
Yeah.
Yes. Okay,
Okay.
sir.
Because the whole data points that you have here is only 10, right? Very small sample. Okay. And
Yeah.
then, they are also almost the same, right? So in that case, there are some problem that basically the model is just like finding the line, okay,
Yes.
using one point. Can you understand what I mean? So I will stop your screen sharing. Open the. Okay, I will clear all here. So suppose you have only this. This represent your 10 data. This point represent your 10 data, right? And from here, you basically can have many lines, no? That passing to that line, isn't it? To that point, isn't it? So
Yes, sir.
you have two. If you have two, so I clear this. So if you have two data point, okay, each point is 10, right? So now you can have a better line, correct? So at
Correct.
so if you have three, then you can have a better line also. So it's confirming your what you are doing. That's exactly what you just did. Okay. So I'm just explaining why you repeat your data can actually help you to improve your accuracy, isn't it? So from
Yes.
65 suddenly becomes 65. So you can copy 3 times or 4 times. Will it increase? Then the question, if I copy 100 times, will it become 100? No. Right? There are certain limit. Even if you copy so many times, it will not go beyond a certain percentage. Okay. So yes, copy data help, okay, to improve the accuracy, but it will not. If your data is really very bad, so it will not go up to 100 still. Okay, with this, I want to end this class. Thank you very much for today. Oh, next week is holiday, right?
Yes, sir.
Oh, okay. So enjoy.